Hey y'all, let's take a look at the term that's called least common multiple. Let's break that down into chunks. Least, of course, smallest, right? Common means it's, among or between a couple or among three or more. Multiple, what is a multiple? Well, what's a multiple of 10? And don't say 2 and 5 and 10 and 1, because those are not multiples of 10. 10 is a multiple of 10. 20, 30, 40, 50, and so on. What are multiples of 8? 8. 16, 24, and so on. So when they say find a least common multiple of 3, 5, and 10, you're looking for the smallest number that exists that are multiples of 3, of 5, and of 10. In other words, for example, you might go, oh, let's see, I'm going to do the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, blah, blah, blah. Okay, 5, 10, 15, 20, 25, 30, 35, 40, blah, blah, blah. 10, 20, 30, 40, 50, and so on. Wait, I forgot. Blah, blah, blah. Okay, you could look at this and go, wait, the smallest number, oh, look. There's a 30, 30, and 30. I found it, yay. Okay, then mom sprinkles essential oils on you for doing a good job. Okay, anyhow, but you don't want to do that. That's like trying to cut the grass with a pair of scissors or something. It's crazy. But there's a method of doing this, which is pretty cool. And I'll show you what this is. All right, here we go. This is what I'm going to do. Remember the factor trees? We're going to use factor trees for 3, 5, and 10. You ready? Factors of 3, 3. Factors of 5, 5. Factors of 10, 5 and 2. Okay. Well, what we're going to do is we're going to take everything has to be common and everything has to be included. Okay, so if there is something common among three of, okay, sorry, we glitched there or something. Anyway, okay, what we're going to do is we're going to take the most of each prime factor and include it. So you're going to look at each one of these numbers and go, which one has the most 2's, which has the most 3's, which has the most 5's, which has the most 7's, and so on. You pick the one that has the most, and then you put it down in a pile with all the other prime factors and the most. Okay, so let's just go start with 2. This has a 2, so we have to include it. That has the most 2's, 1, 2. Which has the most 3's? This one does. 3. Which has the most 5's? Well, there's a tie between these two. They tie with 1, so we'll include 1 5. Well, 2 times 3 is 6. 6 times 5 is 30. There's your answer. It works every single time. Let's try another one. Let's copy down if you need to. All right, find the least common multiple of 8, 15, and 100. Now, I want you to think. Least common multiple means 8, 15, and 100 all multiply into some number evenly, perfectly. All we care about is the smallest one, the least, that 8, 15, and 100 all divide into. They're a multiple. In other words, if you kept going 8, 16, 24, 15, 30, 45, 60, 100, 200, 300, 4, and so on, which would be the last, the soonest one that all of these strung out would have multiples of. Okay, well, let's break it down into the factor trees again, right? 100. Okay, so 8 will be 2, of course, times 4, and then there's 2 times 2. There's your primes. In other words, this is 8. 2 times 2 times 2. Keep that in your head. 15, piece of cake, that's 3 times 5. 100, okay, you can do this any way you want, of course. 50 times 2, all right? All right, 50, oh, there's another 2, 25. And of course, 25 is 5 times 5. Okay, so here's 100. 2 times 2 times 5 times 5. All right, let's go over the 2's. Which has the most 2's? That one does. It has 3 2's. You can go ahead and multiply them all together if you want to. 2 times 2 times 2 is 8. 3's, which has the most 3's? That one does. Times 3. Which has the most 5's? There's 1 5 there and 2 5's there. All right, 5 times 5 is 25. And there we go. 8 times 3 is 24. And if you do the arithmetic, 24 times 25 is 600. Okay. What that means is that 600 is the smallest number, that if you just kept writing out the multiples of 8, you would eventually get to 600. If you wrote out the multiples of 15, you would eventually get to 600. And if you wrote out the multiples of 100, you would get to 600. That is the smallest number that is a multiple of those three numbers. And that's the method, the most of each prime factor. Okay, let's try another one. Go ahead and do the factor trees. Pause this and do the factor trees and see if you can come up with a number. Okay, we'll do 30, then 75, then 80, and then 30 is just 6 times 5. That's going to be 5 there, and then 6 there, and then 2 and 3. Okay, so let's put that down here. We got 2 times 3 times 5. That's what I got there. Okay, 75, of course, that's 3 times 25. And then 5 times 5. Okay, so I got 3, I got 5, and I got 5. 80, well, I don't know, 40 times 2 is a good enough way to start as anything. And then we can keep going, 20 times 2, 10 times 2, 5 times 2, and that's it, 1, 2, 3, 4. So 2 times 2 times 2 times 2 times 5. All right, let's just start with 2's. Which has the most 2's? Obviously this one does, right? 2 times 2 times 2 times 2 is 16 times something. Which has the most 3's? Well, there's a 3 and there's a 3. It's a tie, so times 3. All right, which one has the most 5? There's 1 5 there, 1 5 there, and there's 2 5's there. So 5 times 5, let's just put 25. Okay. Well, what's 16 times 3? We can do the arithmetic. That's going to be 48. Times 25 equals 1200. And that, my friends, is the smallest number that 30, 75, and 80 will all divide evenly into. That's called the least common multiple. That's the definition. That's the method, so you can use that from now on, okay? Ooh, we can do 560, 588, and 1250. That's a giant one. Okay? We are going to have these kinds, so let's go ahead and try it. Pause it and try it. Okay. Well, let's do 560 first. Easiest thing would be just 56 times 10, right? Okay, that's going to be 2 times 5. 56, we know that's 7 times 8. 8 is going to be 2 times 4, and then 4 is 2 times 2. Okay, so good grief. 1, 2, 3, 4 2's. And then a, what is that, a 3 and a 5? No. 1, 2, 3, 4, a 5 and a 7, my bad. Okay, it's 5 and a 7. Oof. 588, you're going to have to probably use a pencil and paper to figure out all this. 588, I'm just going to take this down here. You know it's an even number, so you might as well just go ahead and do 2. And it's going to be 294. And you might as well just go ahead and do 2. Okay, that's going to be 147. Now, you could look at 147 and go, well, the digits add up to 12. 12 is divisible by 3, so I'm dividing this baby by 3. So 3, and you'd find out that that's 49. Well, of course, we all know that's 7 times 7. So let's take a look. 1, 2, then a 3, then a 7, and a 7. Okay, that good enough? All right, so let's go. That's going to be 2 times 2 times 3 times 7 times 7. That is 588. Wasn't as bad as I thought it was going to be. 1250, piece of cake. You know, you can just go 125 times 10, easiest thing. Then 2 times 5. And then 125, you know that's going to be 5, right? 5 quarters go into $1.25, so that's a quarter. So then 5 there, and then 5 there. So I got myself a 2. I got 1, 2, 3, 4. Is that right? Yeah, 4 5's. 5, 5, 5, and 5. Okay, now let's start with 2's. Which has the most 2's? That one does, right? 2 times 2 times 2 times 2 is 16. Which has the most 3's? There's only one with a 3. Times 3. All right, which one has the most 5's? That one does. 5 times 5 times 5 times 5. Good gravy. That's 25 times 25. Holy cow. If you do the arithmetic, you'll find out that that's 625. Which has the most 7's? This one does. That's times 49. Good gravy in the morning. Excuse my language. Whatever the answer to that is, that's the LCM of 560. We could probably do this. 48 times 625 would be 5/8. 30,000 is what that's going to be. 30,000 times 49. That's a big number. 1875 times 16. Wow. 3 times 49 is 147. And then 1, 2, 3, 4. 1, 2, 3, 4. That is a big number. 1,470,000. That's the smallest number that 560, 588, and 1250 all divide into. Or you could just go like this. 560, 1120, 1680, and just keep going all the way to a 1,000,000, and then you don't do that. Okay. All right. Here's where it gets interesting. Go ahead and pause and copy if you need to. Well, you know, once we do something and it works, which we just did this method and it works, just because you see A's and B's and all that jazz, just do the same. Who cares? Do the same thing. It's the same exact thing. So take 15 and 10. You probably can even see what 15 and 10 both go into, right? I mean, what did 15 and 10 both go into? 30, right? But if you wanted to test it out, you could go like this. 15, you could say, these are going to be relatively easy compared to that. You're never going to see anything that giant with variables. 15, you can go like this, 3 times 5. And over here, 10, that'd be 2 times 5, right? All right, a squared, you can just go like this. A times A, and then B, and then there it is, right? Then A over here is an A, and then B to the third, B times B times B. I'll stop right there. Tell me the method, or think about this. What's the method now? Now that you've done this, what's the method here? What did we do down there at the bottom of all these? Whatever we did there, we're going to do here too. Exactly the same thing. No change. That's what algebra is. You just apply all this stuff to A's and B's and X's and Y's. Well, you tell me what I'm going to choose now of just the numbers. Which has the most 2's? 10. There's a 2. Which has the most 3's? 3 there. Which has the most 5's? Oh, they both have a 5. So I'll choose that. So 2 times 3 times 5, 30. That's my number. Now, let's do exactly the same thing with the A's and the B's. Which has the most A? Oh, A to the second. Oh, A times A is A squared. Which has the most B there? Oh, B to the third. Oh, there it is. Okay. And that is my answer. That's the smallest term that 15A squared B will divide evenly into. And 10AB cubed will divide evenly into. And I'll show you a trick in just a second that makes this 10 times easier. Well, I'd say 9.72 times easier. Okay. Let's do it again. You try this one. Pause it and try the same thing. Break this up into chunks, then choose the chunks. Pause it and try it. Okay, I'm assuming you paused it. So 4, I'm going to go 2 times 2. X squared is X times X, and then M is just M, right? All right. 6 is 2 times 3. X cubed is X times X times X, and M is just M. All right. Which has the most 2's? That one does. That's going to be 4. Which has the most 3's, or has more 3's, as there's only 2 of them? That one does, has 3. So the answer is, to the number part, it's 12, right? Which you knew, 4 and 6 go into 12. That's the smallest number. Big whoop, okay? Now, my question is, X squared and X cubed, which one has the most X's? Oh, X cubed does. There we go. Which one has the more M? M, and there you go. Okay. So let me tell you something. Let me go ahead and tell you. These are easy enough numbers, so where most of the time you can do these by yourselves. 4 and 6, oh yeah, 12. All you need to do for all the other ones, you don't need to do this anymore at all. All you need to do is look at which one. Now make sure you're doing the right kind of problem, okay? We're not doing the other types where we chose the smallest one. We are looking at this at least common multiple. In this case, just choose the one that has more of an exponent, a higher exponent each time. Or if there are 3 of them, has the most. Or 4, or however many. That's all you need to do. There was a tie because these are both m to the first power, so you just choose that one. That's all you need to do. All right? All right, let's do one last one here to show you exactly what I mean. Okay, well, forget 12 and 14 right now. Let's just use our trick. We'll mess with those numbers in just a second. All right? Let's go with the x squared and x to the third. What's going to be the LCM one I'm going to choose? X to the what? Third, right? That's more. A, and then A, of course, will be, no surprise there, m squared and then m to the fourth. Which one we're going to choose? Is m to the fourth. Okay. So we don't even have to think about this anymore. To get LCM, it's got to be the higher exponent value of each variable. All right, now let's do 12. 12 we can probably do in our heads, right? That's going to be 2 times 2 times 3. 14, we know that's 2 times 7, right? Okay, let's take a look at this now. Which one has more 2's? This one does. That's going to be 2 times 2. Which one has more 3's? That one does as well. 3. Which one has more 7's? That one does. Okay, so 2 times 2 times 3 is 12. 12 times 7 is 84. And 12 and 14 both go into 84. And x squared and x cubed go into x cubed. A goes into A goes into A. M squared and m to the fourth go into m to the fourth. And there we go. That's all you need to do. Okay. All right. Let's go ahead and try, pause it and try A. Find the least common multiple of 14, 20, and 30. Go ahead and give it a whirl. Okay, well 14, I'm just going to go ahead and write what you should have as your prime numbers. 14 will be 2 times 7. 20 is going to be 2 times 2 times 5. 30 will be 2 times 3 times 5. All right, which one has the most 2's? This one does. 2 times 2 is 4. Which one has the most 3's? This one does, just 1 3. Which one has the most 5's? There's a tie for first place, so just choose 1 since there's a tie. And then there's a 7, right? There we go. So 4 times 3 times 5 times 7, that's going to be 12 times 5 is 60. 60 times 7, well 6 times 7 is 42. So 60 times 7 is 420, and there you go. That's the smallest number that all three of those numbers will divide evenly into. All right, pause it and try B. All right, 75, let's go ahead and do this. Let me see if I can get this in my head here. That's just going to be 3 times 5 times 5 will be 75. 120 will be, let's see, 2 times 2 times 3 times, well, that should be 3 2's, shouldn't it? 2 times 2 times 2 times 3 times 5. That's going to be 120. All right, let me separate these things. Okay, that's 15, yep. Okay, 315, oh boy. That's going to be, that'll be 5 times 63, which is 7 times, so that'll be 3 times 3 times 5 times 7. That's 315. Okay. All right, I think that's right. 1,505 times, yeah, okay. All right, let's go. This has the most 2's, so 2 to the third power is 8. That's what we'll say. That has a 3. This has 1 3, but that has 2 3's. So it's going to be 3 times 3 is 9. This has 2 5's, 1 5, 1 5. So we're going to choose 2 5's. That's 25. And then only one of these has a 7, so there we go. All right, well 8 times 9 is 72. 72 times 25 is 1,800. 1,800 times 7 is 12,600. That is the smallest number that all three of those numbers divide evenly into. Okay, foolproof method, works perfectly. Okay, pause it and try C. All right, well, I'm sure you know that 4 and 6 go into 12, so we'll just go ahead and call that. And again, all we're doing in this one is choosing the higher one. So a to the third and a to the 10th, we're going to choose a to the 10th. B to the fourth and B to the second, B to the fourth. Really quickly, I want to make sure you understand something. Now, I've had kids say, well, wait, no, a to the third doesn't go evenly in a to the 10th because 3 doesn't go evenly into 10. Yeah, it does. Well, in this case, it does. Can you divide a to the 10th by a to the third? You're not worried about 3 going into 10. Remember how we divide, right? What's the method we use here? What's a to the 10th divided by a to the third? A to the what? 7th, right? We're subtracting. Okay, you don't have to worry about that at all in finding the LCM at all. All you need to do is choose the higher one. But yes, it does absolutely go into their a to the 7th times. We're not worried about 3 going into 10 as integers. We're worried about subtraction. Okay, so anyway, this is the correct answer. All right, last one, D. Go ahead and pause it and try this and see what you get. Okay, let's do 12. That's going to be 2 times 2 times 3. 20 is going to be 2 times 2 times 5. So they tie for 2's. So we'll choose 2 2's. was kind of weird to say. And then there's 1, 3, and then there's 1, 5. All right, so 2 times 2 is 4, times 3 is 12, times 5 is 60. So 60 is our number, and the rest of it's a piece of cake. X to the 4th or X to the 6th? X to the 6th. Y squared, Y? Y squared. M to the 3rd, M to the 3rd? Well, it's the same thing. There you go. Okay, and that is it. All right. Give those a whirl today and see how you do. And we'll see you guys next time. Thanks. Have a great day.